Have you ever wondered how a speaker turns electricity into sound that you can actually hear? It starts with a signal from your audio device, usually electrical current that changes in strength and timing to represent the sound you want, like speech or music. That signal goes to an amplifier, which boosts the signal so the speaker can produce enough energy without changing the basic shape of what's being sent. From there, the speaker's driver, most commonly a dynamic driver in many everyday speakers, does the real work. Inside a dynamic speaker, there's a permanent magnet that creates a steady magnetic field, and there's also a voice coil, which is an electrical coil attached to the speaker's cone or diaphragm. As the audio signal changes, current flows through the voice coil, and that creates a changing magnetic force that pushes and pulls the coil. Because the coil is mechanically linked to the cone or diaphragm, that motion turns electrical changes into physical movement. The cone doesn't move randomly. It moves according to the signal's pattern, moving back and forth to compress and rarefy the air around it. Those pressure changes travel through the air as sound waves, reaching your ears as the same pattern you started with, just translated from electricity into air pressure. Now, here's a helpful way to picture it. The speaker is essentially a precise mechanical translator, with a magnet and coil turning current changes into controlled motion, and the cone shaping that motion into waves in the air. But not all speakers work exactly the same way. Some modern devices use different driver types, like ribbon or planar magnetic designs, where the moving element is laid out differently but still converts an electrical signal into motion using magnetic forces. There are also electrostatic speakers, which work differently. Instead of a voice coil, they use electrically charged plates and an electric field that attracts and repels a thin diaphragm. Even then, the core idea remains the same. The audio signal controls a force. The moving part vibrates, and the vibrating surface creates pressure waves in the air. With any of these, the goal is the same: convert the electrical waveform into accurate, controlled movement fast enough to match the frequencies present in the audio. So why do speakers sometimes sound distorted or not right? The biggest practical factors usually involve how much the driver can move and how efficiently it converts motion into sound. If the amplifier sends more power than the driver can handle, the cone may reach limits where it can't follow the signal cleanly, producing distortion. Materials and design also matter. The suspension that centers and supports the cone, the stiffness of the diaphragm, and the way the driver's parts resonate all influence how faithfully it follows the signal. For this reason, speaker systems often include crossovers in multi-driver sets, splitting the audio into frequency ranges so that each driver handles what it does best. In a typical multi-speaker system, you might have a woofer for lower frequencies and a tweeter for higher frequencies, and the crossover network routes the right portions of the signal to each one. That helps drivers avoid working outside their most linear ranges, which generally improves clarity and reduces strain. Another practical piece is the enclosure, especially for woofers. A speaker cone moves air both in front of and behind it, and without proper enclosure design, those pressures can interfere with each other. The enclosure helps control how rearward sound mixes with forward sound, shaping the bass response. Whether the system uses a sealed or ported enclosure, the air trapped and the airflow tuning affect how the driver produces low frequencies. At the same time, placement matters. A speaker in a room interacts with walls, floors, and corners, which can boost or cancel certain frequencies depending on where it sits and how you listen. That's why the same speaker can sound different in different rooms, even when the electronics and driver are unchanged. If you're trying to get more out of your listening, start with the basics that influence what you actually hear. Use a good source signal and avoid clipping at the playback level, since clipping means the waveform is flattened and the speaker is asked to reproduce a less accurate shape. Give the speaker appropriate power, enough to get clean volume, but not so much that it distorts. Position speakers thoughtfully, especially for bass, and avoid blocking the drivers. Also, remember that audio isn't just one frequency. It's a time-varying mix of frequencies, and a speaker is effectively tracking that changing waveform moment by moment through its electrical to magnetic to mechanical conversion. So, to sum it up, audio signals become electrical changes that an amplifier boosts, the speaker's magnet and voice coil, or other driver mechanisms, convert those electrical changes into controlled motion, and that motion makes pressure waves in the air that you hear as sound. Thanks for watching. If this helped, please like and subscribe, and tell me in the comments what you want to understand next. First, will also share future videos on how audio systems like amps, equalizers, and room acoustics affect what comes out of your speakers.